Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, it's Thursday, so you know what I always say on Thursday, I can see the weekend from here. It's almost Friday, it's almost Happy Aloha Friday. Now, you've got LS7 out, and we'll work with it. You probably want a pen or a highlighter or something. So, and you've got a white sheet, so I'm going to have you write a few things down on your white sheet. Now, my job today, is to totally get you ready for tomorrow's test. Test number 2 of the quarter. I think it's test 7 of the tests, including first quarter as well. So in your lesson planner, you'll want to put down test and triple R. Now, again, here's my job. My job is to tell you the topics that are going to be on the test, not the specific questions. Although it's possible some of the exact questions will come out, but I'm not going to tell you that. Well, sometimes I do. But anyway, so what's your job? I do my job to prep you and to review with you what's on the test. What is your job? To triple R. If you do not triple R, you probably aren't going to do very well. There are a few of you out there that could do okay. But most of you, if you don't triple R, and you don't really triple R LS7 and Psalm 139, then it won't be pretty. Okay? Now, I've tried to review a lot with you. What's your guess? If, let's say that people didn't study, they might be able to get a C. Maybe most people might be able to get a C. My guess is that's not your goal. A C, like a 75 or a 72. You probably, are aiming a little higher than that. Hopefully you've set your sights on a lot higher than that. Okay. So you've got LS7 out, and here we go. So from LS7, everything there in that top box that I've circled. Where it talks about cell division and GRR, G-R-R, GRR. So I'm going to ask you that. I asked you that yesterday. So GRR, the jobs of cells and why they divide. For growth, the G1, R, repair, healing, and then also reproduction. By the way, healing, do you ever think about it? It so glorifies God. So let's say you get some damaged tissue, a cut maybe, okay, minor or maybe not so minor. So have you ever had stitches? Yeah, right, you probably can't see it right there. So are you going to tell the story? You want to hear the story of how I got those stitches? You do? All right, I made a bad decision. How old were you? I want to say 10. Okay. And what happened? We had a dog by the name of Trigger, and we were in South Dakota. And Trigger was bothering me in some way. I don't remember exactly. So you know what I decided to do? Slap Trigger. So, slow-mo. That'll teach you oh wait, what's that wet? I sliced I can see the scar. You can't see it, but I can see the scar right there. I mean, I ripped open the flesh. You know what I hit? I hit one of his incisors. The meat cutting teeth, real sharp. Yeah, I hit it right there. And it just split me open. So, off to the doc. I think I got 5 stitches probably for that. So, anyway, I'm not going to tell you how I've had stitches twice. But here's the point. when you get stitched up, that really doesn't heal you up. Did you know that? What does it? Somehow the cells know to divide and divide and divide and divide and divide and to grow back together. How do they know? How do they know there's damage or an injury? And then how do they know to divide and divide and divide and divide and divide and divide and divide? How do they know? God designed them that way. It's a divine design. Isn't that cool? So you can just go, self-healing cells, there's got to be a God. I mean, it's just got to be. No way all by itself. Okay, so now I've got down here, it says most organisms reproduce when specialized cells from two different parents combine. So you know what that is. It's sperm, egg, new cell, zygote, the first cell. So, and I've got it down here at the bottom. There it is at the bottom. I should have put sperm plus egg yields or equals a zygote. Same thing. You know what it is. Okay. Then, how are we doing time-wise? Because I've got to give you a little break. The regular sequence, this is in the second box now. That was the top box. The regular sequence, I'm going to draw myself an arrow here so I'll remember. Pardon me. So here it is. The regular sequence of growth and cell division that cells undergo is called the cell cycle. Cycle is ongoing. Keeps happening. Cells keep dividing. Okay? So, and then you've got to know what the two cells are called when a cell divides. So cell division, and these two cells are called daughter cells, right? And then at the top, I put at the top where it says cell division. Do you see that? Cell division, we call it fission. Cell division, that would be fission. So you know I'm going to ask you that. Okay, I'm going to ask you, what do you call it when the cells are getting ready to divide? They reproduce everything. Everything inside the one cell is reproduced. So new nucleus reproduced, all the little pieces of equipment on the inside, the organelles, they're reproduced. Everything is reproduced. So the cytoplasm, the liquidy part of the cell that the organelles are found in, they reproduce. How does it know? It's a wonderful divine design that brings God much glory. So anyway, so here's the deal. So you got your daughter cells. So I want to know now, what is the reproduction of the chromosomes? So that there's a copy of the chromosomes that are made, which is made of DNA, right? So that each daughter cell gets a complete set of chromosomes. And they pair up, and they know how to pair up. Pair number 1, they always pair up together. Pair number 2, they always pair up together. Number 3, how do they know they're 2 or 3? Well, they don't know they're a number, but they know they're supposed to pair up with that other one that's just like it. So, in each cell. Amazing. And that is called replication. And I'll read you what it says right here. The process by which a cell makes an exact copy of the DNA in the nucleus is called replication. So circle that. And it says at the end of replication, the cell completes 2 identical sets of chromosomes. Those are those chain-like bodies. So, do you want to draw some chromosomes? Okay. Here's what they kind of look like. They honestly do kind of look like this. See down at the bottom? Oh, you're so artistic, Mr. C. Right there. That's kind of what chromosomes look like, if they're not magnified a whole lot. So that would be a chromosome. So anyway, and then I do want you to know, I'm going to ask you about mitosis. Remember, I gave you the hint, MN. Mitosis is the stage of cell division where N, so it's MN, mitosis is a stage of cell division where the nuclei are reproduced. So each daughter cell gets a nucleus. It's the same. So, and that's why I drew the arrow down there. Do you see the arrow I drew down there? Mitosis. And I drew an arrow to nucleus. You probably want to do that. I'm going to ask you that tomorrow. So I'll probably say, during mitosis, what is reproduced? And I almost certainly will say it just like that. And what is it? The nucleus. So anyway, the nucleus. Now, over on the right side, I should have had you do this. Do you see how I X'd out over on the right side where it says cytokinesis? X that out. You don't need to know that. No need to know that. Okay? So anyway, those are the things I want you to know from LS7. Now, I'm going to do a few things from LS8 in just a little bit. That will be on the quiz too. I'm going to turn you over to Mr. Gilbert. He's going to review anything with you. If you miss something, he'll help you out with that. If you need clarification, what does this mean? Clarification. You'll raise your hand and ask him. So if you've got a question for Mr. Gilbert right now about what I just went over, raise your hand. He's your man. So, and I'll be right back to go over LS8. Mr. Gilbert. All right, I'm back. Now you've got LS8 in front of you and you've got something to write with, highlighter probably, and a pen or pencil. Okay, are you going to ask us a few of these particular terms on the test? I am. Only on the left side. Things on the left side. I'm going to stay on the left side for right now. Now genetics is maybe my favorite area in 8th grade, favorite topic in 8th grade. Favorite unit in 8th grade to teach. It's just fun. Genetics. So, I want you to find the term genetics, and it's a scientific study of heredity or inheritance. You see it right there? I've circled it. It's the first thing I've circled, genetics. What's the root word for genetics or genetics? Gene. It would be a gene. There it is, genetics. So there it is. Now, here's what heredity is. Your heredity is where you get genetic traits from your parents. It's passed from your parents to you. That's heredity. Up at the top, you see heredity. Up at the top. See it up at the very top, heredity. And here's what it says. Heredity is the passing of physical characteristics from parents to offspring. Now here's one physical characteristic, okay? Or a trait. It's known as a trait. Okay, I'm going to have to take my hat off to show you. Some people, their hair comes to a point, and an informal name for that trait is a widow's peak. I don't know exactly why it's named that. I don't know about the derivation of the name. I just know a widow's peak is where some people have kind of, it comes down to a point. The hair comes to a point. So let me see if I can actually show you this. So do I have this to show you? I might. Let's see if it's here. Ah, there it is. Okay, I think I can show you this. Okay, have a look at this. Let's see if this will work. This is the first time I've tried that. Okay. Do you see that person's hair? Where when you pull the hair back, you can see that it comes to a point. That's a widow's peak. It's inherited. Okay. And let me just see what it says about it. Okay. And here's what it says. Widow's peak is likely controlled by Let's see, multiple genes, many genes, not just one or two, but many genes. So widow's peak comes to a point. Okay. Now I'd like you to have a page. Besides having a page, a kind of a new science topic. Pardon me, genetics, genetics. So I'd like you to have a page in your journal, start a new section in your journal, genetics. And then I want you to write down some of these traits. So you can write down the word trait, and you're going to write down yes or no whether you have the particular physical trait that I'm talking about. Okay? But I better finish up LS8 first. So finish up that section in your journal, genetics at the top, and then maybe skip 2 lines down and put traits, Traits, and here's the word right here. There it is. I'm going to circle it, and it says each characteristic, such as height or seed color, is called a trait, right above genetics. You see that? Trait. Trait. So circle that and underline what it's called. Any physical characteristic is a trait. Okay? That would be a trait. So far you've circled heredity, the passing on of physical characteristics from parents to offspring. And then it could be plants too, because it's weird, but with plants we call it male-female parts that produce sperm and eggs. Okay, so you've got traits, a characteristic, a physical characteristic, scientific study of inheritance, genetics. You've circled that. Okay, and then down below on the left side, I'd like you to circle gene. Today, scientists use a word, gene, to describe a factor that causes or controls a trait. That's a gene. It's like a chunk of DNA. So right above gene, I'd like you to put a chunk. It's kind of informal, Mr. C, I know. A chunk of DNA. I'm writing chunk of DNA. Right above gene, bottom box. Chunk of DNA. Okay? There it is. A chunk of DNA. A section of DNA causes, or that's called a gene, and they cause traits. These sections of DNA, genes, cause traits. So you draw an arrow from gene up to trait. Kind of the idea it causes it. See how I did that? Draw an arrow from gene up to trait. Do I have to do everything for you? You can do it on your own. So away you go. Okay. Okay, I've got to hustle. All right. Did I get everything on LS8 that I want you to know? Heredity, passing on of physical characteristics, parents to the children. Children. Kind of weird to talk about children when you're talking about plants. Okay. Individual characteristics are called traits. And then the scientific study of inheritance is genetics. And then a chunk of DNA that causes traits is called a gene. Okay. I have 6 minutes to do a few more of these. So you've got down widow's peak. Or you could put hairline shape. There it is, a widow's peak. So put widow's peak and yes or no whether you have it. Now I just want to show you, watch this, watch me, I'll pull my hair back here. So you can see that I don't have a widow's peak. See that? Mr. C, that is so not funny. So did you have a widow's peak? Now can you imagine me, say when I was 10 or 12, I had what was called a crew cut, and I used to put wax on the front edge of my hair so it sort of stood up right in the front. Okay, it was cool. I was so cool when I was 10, 11, and 12. Were you really? I don't know. Maybe not. But anyway, that's what I used to do with my hair. You know, I had that really cool crew cut. Okay, here's another trait that's pretty cool, and you can see if you've got it. So it has to do with the ears. So are you going to show us on the computer? I can. First, I'll describe it to you this way. It's called attached earlobes or unattached. Here's your earlobe right here. Boop, boop. This chunk of cartilage right there. Chunk of cartilage, soft tissue. Now, if it looks like your earlobe was sewn to the side of your face, so it doesn't hang down, there's no blob of cartilage hanging down, that's attached earlobes. So mine are unattached. Boop, boop, unattached. So attached earlobes, unattached. So you can just put attached earlobes, E-A-R-L-O-B-E, and then yes or no. Do you have attached or unattached? If you need a little help from someone to, Mr. C, I can't see my earlobes. Okay, well, maintaining social distance. You know, you could ask a neighbor, and there are some that are sort of in between. It's kind of hard to tell, but here's the deal. If this part down here, it's like, it looks like it was sewn to the side of your face all the way down, that's attached earlobes. Okay. You want to see the pictures? Okay. Here they are. So it would be on the left is unattached. So I have unattached and attached on the right. Let's see if I can move it in there. See that? Okay. Pretty cool, huh? Okay, so that's a second trait that we've dealt with. We have time for maybe two more. All right, this is a fun one. Oh, I didn't read the data to you on this. Here's what it says. It says it's likely that this is a multiple gene trait. Not just one or two genes cause it, but many genes. We call that multiple gene. Okay, the next one. It's pretty fun. And let's see, this probably is a multiple gene trait as well. And here it is. It's called tongue rolling. So I'm not being impolite. I'm just going to, Mr. C, you know, don't go home and tell your parents, Mr. C stuck his tongue out at us today. Well, I was showing you the tongue rolling trait. Here it is. Can you roll your tongue like that? Like this. Tongue rolling. So you could put tongue rolling. Tongue's a little bit of a tricky word. T-O-N-G-U-E. Tongue. T-O-N-G-U-E. Tongue rolling. Can you roll your tongue? Now, some people just can't. Now, it doesn't mean anything. You know, it doesn't mean that you're deficient in any way. You just don't have, you didn't get the genes to cause you to make the muscles that can move your tongue in that way and roll it. Tongue rolling. You just didn't get the gene to make the muscles. Now, is there any tongue rolling Olympics where it's like really important to be able to roll your tongue or not? Of course not. It's not important. It's just kind of fun. It's a fun genetic trait just to see if people can do it or not. Now, here's what it says. It says about 70% of people of European ancestry could roll their tongues and the remaining 30 couldn't. But there have been other studies that show, you know, we're not sure about that. You want to see what it looks like? Here it is. Tongue rolling. Oh, let me see just a second. Is that guy? That guy kind of had hair like I had. I can't tell exactly, but his hair was kind of like mine. except I had it was called a flat top actually, where I put wax on the leading edge. Okay, tongue rolling. Next is dimples. Where you have those dimples, they kind of dip inside. Dimples. Dimples. So smile for your neighbor. Just smile. Now, I don't think I have dimples. Pretty sure I don't. Dimples. So you can put down dimples. Yes or no? Dimples. And it says it's probably controlled mainly by one gene, but maybe influenced by others. Dimples. And it says this. Dimples are highly heritable, meaning that people who have dimples tend to have children with dimples, but not always. Here's some nice dimples on a person. Dimples. Look at those dimples. Those indentations. Okay? Nice smile, nice dimples. All right. So dimples. Should we do one more at least? Okay, these genetic traits. All right, what's next? Oh, handedness. Handedness. Left or right handedness. Now I'm going to read the whole thing to you about it. And then while you're writing down handedness, and you can put underneath that L or R for left or right. Handedness describes our preference for using our left or right hand for activities such as writing or throwing a ball. Now, I was a right-handed pitcher. Overall, about 10% of people are left-handed, but the number varies depending on the culture from 0.5% all the way up to 24%. Some have reported that handedness is controlled by just one or two genes, but this is not the case. Multiple studies present evidence that handedness is controlled by many genes. So it's a multiple gene trait. And then it says environment also plays an important role. In some cultures, actively discouraging left-handedness happens, which is too bad because, the world needs more left-handed pitchers. You know what I mean? Mr. C, were you a baseball player? Is that why you're saying that? Well, yeah, I was, yeah. And, we didn't have enough left-handed pitchers on our team. I don't think we had any, actually, in Little League. So, now I remember when we played on the All-Star team, my good friend Tony Beard was a left-handed pitcher, and he was really, really good. So, hey, my memory's working today. That was, how long ago, Mr. C? 60 years ago that I can recall his name. So, anyway, pretty good. All right, well, I'm going to stop there. We'll pick it up. We will pick it up probably Monday because tomorrow's a test, right? So we'll pick it up on Monday with freckles. So I'll give you the data on freckles and then curly hair or straight hair. So it's fascinating, these genetic traits. I love this. I bet you kind of think it's kind of interesting too. I mean, how can you not? Now, I'm going to just remind you one more time. Triple R, folks, you know what's on the test. Now, I didn't mention, I'm mentioning it now, Psalm 139, 13 and 14. For you formed my inward parts. You knitted me together in my mother's womb. I praise you, for I'm fearfully and wonderfully made. Wonderful are your works, me, and my soul knows it full well. Now, here's the point. Who gave you your genes? My mom and dad. Yes, but who controlled that process? God. God designed you using your mom and dad's chromosomes, their genes. That's how he designed you. It says, you formed my inward parts. You designed us, God. So I look the way that you wanted me to look. There's a lot of comfort in that. I love that. Hey, the way God designed me, I'm excited about that. I just, I'm pumped about that. I look the way God, designed me. So, I can be proud of that. I can be proud of the way God designed me. And, just be a blessing to others using the way he designed me. So, pretty cool. Okay, I'm going to turn it over to Mr. Gilbert. He'll cover anything in the second half. He'll do anything that needs to be cleared up or clarified. So I'll turn it over to him. Thank you, Mr. Gilbert. Do you thank Mr. Gilbert for helping you? He helps you every day. So good on him, as they say in Australia. Thanks, Mr. Gilbert. I appreciate it, how hard you work. So, Mr. Gilbert.